My name is Takuka Penda, and today I'm going to walk you through a task from Spark Foundation that has to do with um, K-means clustering algorithm. And so, just to give you a background of the task, so we're going to perform a K-means clustering on the Irish dataset, a popular dataset of flowers, and the essence of this task is that we want to uncover, all right, hidden patterns within the Irish dataset, okay, and by grouping similar flowers, right? And particularly based on their measurements, right? So, this task will do is to help us to understand the data set better, right? And to potentially identify underlying relationships between the features and the resulting clusters. So, I'll just walk you through the a code. So, in the first cell that we have here is the necessary libraries for the tags. So the necessary libraries we have pandas for data manipulation. We also have scikit-learn. Okay, and the scikit-learn have the dataset and the algorithm, the model that we're about to use, which is k-means, right, for clustering, and then we have matplotlib, the pipeplot, which is for the visualization. All right, so the next cell that we have below. So it's where we load the data set, all right? So we use the load Irish function, all right? So that will load the data set um, into the structure containing data and targets. All right. So we have X for um, the data, and then for the features rather, and then we have a Y, right, equals to Irish or target as labels that we can refer to for. Okay, so the next one, the next cell that we have here, right, is where we find the optimal number of clusters, and so we're going to use the Airboy approach, right? The Airboy approach is what we're going to use, and so we have an inertia value, okay, and then we also the initial value is an empty list, all right. So the initial value is just a list to store the initial scores rather for different cluster counts. That's the essence for the initial value. And so we have a for loop that range between 1 and 11, starts at 1 and ends at 11. So we have to loop 10 times. All right. And in each of these loop, what we're going to do is that we're going to create a k-means model, right, with k clusters, which is 10, right? And we're going to initialize this 10 times to ensure that we have a better results, right? And then we feed the model in each iteration. So we see we have k-means dot fate, k-means dot fate, right? So we're going to feed the model to the data, right? And then we assign the points to clusters, all right? So we're also going to store that value, the scores within inertial values, all right? And that's how we see we have a inertial value that append k means dot inertia. All right. So we apply the k means clustering with the optimal number of clusters. So the optimal number of cluster is 3, because if you see the visual at the bottom here, you'll notice that where the curves start to flatten is at 3 at this point. It is at this point that the curves start to flatten. So we have 3. The optimal number of cluster is 3. And so our optimum k is 3. Okay. So now, so we set the optimal number of clusters based on, like I said, where the curve begin to flatten, right? And so we create a k-means model of 3 clusters, right? About three clusters, optimum key. The number of clusters equal to optimum key, and then initial to 10 times. So now the target variable, which was we have y underscore k means equals to k means dot fit predate, and then we apply on the x um, variable that we had previously above. All right, and then we just visualize at the end, visualize the clusters now to see um, what they look like. All right, so we have a scalar plot now at this point, and our scalar plot, we see the groupings of each clusters, and then we have different colors for the three clusters: purple, green, and yellow. So yes, we visualize them and to see them. Okay, so that's the end of this task, and thanks for watching.